Secure Boot was designed to act as a gatekeeper for your computer, ensuring that only verified and trusted software can execute during the boot process. Think of it like a vigilant security guard, carefully checking IDs at the door. However, a new type of UEFI malware has found a way to sneak past this guard, exploiting vulnerabilities and putting your system at risk, even surviving across operating system resets. This particular vulnerability originates from a UEFI application called REBOOT, which is signed using Microsoft's third-party certificate. It is included in multiple system recovery tools, such as HowYar SysReturn, GreenGuard, Radix Smart Recovery, and more. The problem lies in the way this custom PE loader bypasses the usual UEFI security checks. Instead of relying on the standard load image and start image UEFI functions, it takes an alternative route, allowing the execution of any UEFI binary, even unsigned ones, regardless of whether Secure Boot is enabled or not. When your computer starts, the UEFI Boot Manager loads a boot application, such as Grub or the Windows Boot Manager. Before running it, Secure Boot verifies the application's binary against two key databases, DB and DBX. DB, database, contains a list of certificates for software that is authorized to run on your system. Manufacturers preload this database, often including certificates for Microsoft software to ensure compatibility. DBX, database of revoked certificates, maintains a list of certificates that are no longer trusted, typically because they've been replaced or found to be compromised. For example, Microsoft is transitioning from the 2011 UEFI CA certificate to the newer 2023 version. Secure Boot's responsibility is to confirm that a UEFI application appears on the DB list while avoiding any entries in the DBX list. However, here's where things fall apart. REBOOT is signed with Microsoft's third-party UEFI certificate, which is intended for trusted third-party tools. Unfortunately, Microsoft's internal review process for approving such applications seems insufficient to counteract evolving threats. Last year, researchers analyzing HowYar SysReturn software uncovered a file called cloak.dat. This file is an unsigned UEFI application encrypted with a simple XOR cipher. When loaded, cloak.dat decrypts in memory and bypasses Secure Boot integrity checks by calling a custom loading function instead of the standard UEFI load image function. This allows malicious code to be injected into the cloak.dat file, compromising the system. Importantly, the vulnerability isn't limited to systems running HowYar SysReturn or similar tools. Attackers can introduce the REBOOT file themselves, along with a malicious cloak.dat payload, to exploit any system that has Microsoft's third-party UEFI certificate enabled. The exploit's persistence in firmware makes it particularly dangerous, as it can survive operating system resets and reinstallation. Mitigation and prevention. The primary reason this vulnerability isn't a larger issue is that attackers need admin or root access to deploy it. However, because the exploit targets firmware, removing it can be extremely challenging once it's in place. Here's what you can do to protect your system. 1. Update your DBX database. Ensure your system's revoked certificates list, DBX, is up to date. This can block the vulnerable REBOOT file. On Windows, run the following PowerShell command. PowerShell. Get Secure Boot UEFI, select string, pattern, DBX. On Linux, use tools like dextool to verify your DBX list. 2. Disable third-party certificates. If you don't need third-party UEFI certificates, consider disabling them in your system's firmware settings. 3. Verify system integrity. Regularly check your UEFI directory for unauthorized or suspicious files. Tools like UEFI Tool can help analyze firmware images for anomalies. Researchers demonstrated this exploit on a test system running Ubuntu Linux in a virtual machine. The steps involved: 1. verifying secure boot was enabled and db/dbx were up to date. 2. Copying the vulnerable reloaded FE file and a malicious cloak.dat payload into the UEFI directory. 3. Rebooting the system, which executed the malicious payload and compromised the system. In a real-world scenario, the malware would likely operate stealthily, performing actions such as stealing sensitive data or mining cryptocurrency without drawing attention to itself. While this exploit requires significant access to initiate, its potential for damage is alarming due to its persistence and ability to bypass fundamental security mechanisms. To stay protected, ensure your firmware and DBX lists are up to date and disable unnecessary certificates. Cyber threats are constantly evolving, so staying vigilant is key to keeping your system secure. If you enjoyed this video, please like and share it to hack the algorithm.